I'm Andrew Hyatt, and I'm going to talk about EKG and extending how to extend EKG to deal with more structured data. If your EKG is a note-taking application for Emacs, it's sort of unique in the sense that it uses a SQLite database instead of the file system. It has a lot of interesting capabilities, and one of them, especially because it uses the file system, is that it can very nicely deal with all sorts of structured data. And especially because of the way we interact with the file system, I think it's an especially nice system for extensibility. And that's because it uses this thing we call triples. It doesn't, if you look at the EKG code base, you're not going to see, select statements and insert statements and just raw SQL. We use this triples library to interact with the database. And so I want to kind of talk a little bit first about what does that look like? How should we be thinking about this? I believe I have some other videos about this, and if you look at the triples package, there's also quite a bit of stuff written about how to work with triples, how to think about triples, and things like this. Triples are, by the way, standard. They're standard for knowledge graph construction. EKG is the Emacs knowledge graph, at least that's how I envision it. But it's also, knowledge graphs tend to be for standard information, world information a lot of the time. But in this case, we have a personal knowledge graph, and that's fine. These are actually personal knowledge graphs are becoming more important, especially with AI that uses personal knowledge graphs for various standardizing your structured information so that they can be of use by LLMs. And this is something we'll also talk briefly about. Okay, so let's start with just talking about triples. What are triples? So a triple is subject, object, subject, predicate, object. And this is how we represent all the data in the database. So subject is, for EKG, is the ID of the note. And this ID of the note is usually a number, like a unique number. But it also could be, if you're taking a note about a resource, a document like a URL, it could be the URL. And in that case, the unique thing is the URL. And you're saying, this is a note that is adding sort of textual data to this URL. So the ID could be all sorts of things. In EKG, we're kind of limited right now to just numbers and URLs. But with triples, you really could, it is a graph, right? And so you can imagine all sorts of ways we could tie one thing to another. And we sort of do this a little bit with EKG now, where we have these IDs that are not notes in some cases. They're just kind of these objects that represent, I think we use them for inline commands, which have a little bit more complicated thing and need sort of this other ID. So, we do have this a little bit, but in that case, the ID is still just, something pretty simple. But the predicate is you can think of this as a combination of a type and an attribute. And it usually has the form of type / attribute. And a type has many attributes. You could just have one, or could have none, but usually it has one or more attributes. And the object is what it points to. So for example, that object could be text. If we're storing, for EKG, we store the text of a note. So we have, for the predicate, so text. Yeah, so text, if you look here, here's everything we store in the note already. So text would be, the ID is ID of note. The pred is, I think, something like text. Actually, let's not speculate. Let's just look at ekg.el and see how we define everything. this everything is in schema, add EKG, add schema. This is how we define everything here. We see, yes, text. So I'll go into how to read this and how to make sense out of this in a second, but I just want to kind of come back here. And the object is really like, this is the text of the node. Like whatever the text of the node is, that's the object, right? But it could be like a long string, or it could be something that is a pointer to another ID. It could be like, another ID. It could be all sorts of things. So we have structured data already. We have an ID, we have tags, we have creation time, we have title, and we have text, as I went over. So let's kind of just look at EKG add schema. And let's see how it's doing things. Because if you want to extend it, you kind of have to understand how to use triples, how to add new schema. One interesting thing I want to point out is the schema is very, it's designed to be kind of very atomic. That is, it is very normal to have one ID that could be of multiple types, and notes have multiple types. But it is not the case that we have a note and it has all these attributes, like here's the text, here's the creation time, here's the tags, because maybe we have things that are tagged that are not notes. And in that case, we want to separate these concepts. And so you'll see everything is very well separated here. And this is kind of how knowledge graph schema is typically done. So we have, so to start with, we have this tagged schema where we say, okay, we're adding the schema to the database. By the way, the schema is stored. So even if you didn't load the right modules, we sort of still know about the schema because the schema is in the database. And the schema is in the database in the form of triples itself. Usually do not have to think or worry about this, but I think the important thing is that like schema is real, it is stored, and it is possible to, it gives a little bit of a way to kind of deal with the database, even if you don't have the code loaded in Emacs. So in this case, we're saying we have a type called tagged. So anything could have this type called tagged. And when it's tagged, you have an attribute called tag. And this tag is a string. And it's not unique. So you don't see it. By default, nothing is unique. So it's a list. So by default, everything is a list, unless you say otherwise, and then it's a single value. So this is basically saying this tagged, this is a type tagged, and when you are tagged, you can have this property called tag. And that tag is a list of tags. So we then have something a little bit more complicated. We have text. Text has three properties. Text mode. So the text is unique. There's only one text. There's only one mode. The mode is like, is it org mode? Is it markdown mode? And then these inlines, I'm not going to go into them. They're a little bit complicated. But same thing for time tracked. Like we might want any sort of thing time tracked. So we have a creation and modified time that we could attach to anything with an ID in the database. But I want to show kind of especially this thing, which is pretty interesting, which is this is the other side of tag. The tags are also, when you say something is tagged, so let me give an example. So you have a note, and that note has a particular ID and there's a predicate tagged tag on that ID, and it has, let's say that the tag home. Okay, maybe you just want this for nodes, like things about your home. So that home could be just a value, but in our case, we think of this also as its own ID. So this is like this other kind of case besides the numbers and URLs, but there's these, your tags are also IDs, and they also can have data. And we could go kind of a little farther with this. We could say, like, if you want text about your tag, like what does this tag mean, you could do this. We already have, you could just add a text thing to it. So then your tag itself could be a note. And that note could maybe explain what the tag is or things like that. But in this case, the other side, which is you point to a tag, and then the tag also has information pointing back to everyone who points to it. So in this case, there's another tag type. So this is not tag type because the tag itself, like let's say in our example, home, is not it does not have tags. It is a tag. This is the difference. It does not have tags. It is tags. So it knows about tagged, which is this virtual reverse thing. So virtual reverse means this is not actually stored in the database, but it is given to you in the code. So you can retrieve all of the things that are, in this case, tag. So this just points, this kind of references the this bit of schema here. This is basically saying this is the opposite side of the link, and you can use this to find everyone who is linked to you, everyone who has you as a tag. And this is generally true of all these things. You could say anything that has my ID as a object you can make this a virtual reverse property about that, and then you could find all of this. This is the kind of graphy aspect to this. Okay, so this is how it works. And there is, so here's like titled. So, this is just notes can have a title, but you don't need to. Most notes do not have a title in EKG. So most things don't even have this, but you could give a note a title, and then it'll have type titled. If you're like, hey, I want to find everything who has titles, you could just look for every ID that has a title that is of type titled, and you'll get everything that has a title. But what I want to point out is this thing here is that we run a hook. So you could add your schema. You just have to add to this hook. So we've gone over this. All right. Let's go over how do we actually add new structured data. So I've showed you kind of like the basic structured data. Let's take a use case in which we want to add we want to store emails in EKG, and we want to store them with their structured data. That is, who's the to, who's the from, etc. So I'm going to show you some code, which is relatively rough. I'm sure that it has some problems and I need to fix them, but it does show you basically how things are done. I want to use it as a way to kind of like just demonstrate this is how you write an extension. So I wrote this thing called EKG email. We require EKG because we'll need some of those things. We also require triples because we're interacting directly with the triple library. Because EKG doesn't have this stuff, right? We're building our own stuff. We need access to this layer underneath. And so we have our own schema. And here we're saying we're going to add the schema to EKG DB, which if EKG is running, it will be EKG DB will be it will be the database. So you don't have to really worry about if this is bound or if it's correct. Like this is run when, in the hook to add schema, we've already set up the database. So you can be sure it's going to be fine. Just use this variable EKGDB. And we're going to give it a type. These types are unique. So you can write something that is like email, but if someone else writes something that's email, and then, these are both contributions that people use in EKG, that's not good. There's going to be a conflict. So I think right now think of it like packages. Like I would say, if you have if you're using this just for yourself, you don't have to care. If you want to publish it, well, open a discussion on the EKG messages in GitHub, the discussion forums on GitHub, or open an issue, and we could talk about the best way to name this stuff. But then we have our variables. So there's 2. There could be multiple 2s. So this is, again, it's not unique. And it is a string. And then we have from. There's only one from, so it is unique. And we have CC. One thing you might say, like, well, what about the subject? Okay, we don't need the subject because we have title. If you just look here, we have a title. And so this is kind of where this sort of fractured schema thing comes in. Like, you don't have to say everything that something has, because often there's these concepts that kind of extend beyond types. And title is one of these things. One of the interesting things is something could have multiple titles. So title is not unique, but for a message it is unique. But that's fine. We'll just have one title on a message and on an email message that we're going to store. So all we really need is 2 from CC. Of course, you could have BCC. I'm sure you could have message ID and things like that. But this is just a demo. This is all I think we need. And then, of course, it depends. What do you want to do with these? I don't have a strong opinion, so I'm just kind of like doing this as an example. So we add our this new thing as a hook. It will add it to the schema. And then we have this. So I want to describe what's going on here and why you need to do this. So we have these EKG metadata parsers. So what is the metadata? So let me just kind of show you, like this part here, this is the metadata section. Okay, so when we have something here, like for example tags, we need to understand how to read this. And so you put something in there. How do we get it from that textual representation back into the EKG note structure, which can then be saved in our database? So this is what the metadata parsers do. And so they use what is going to be like, this is the field name that is going to hold the to field. And this is the function that is going to update the data with the results of what we're finding in this to field. And same thing with from, same thing with CC. And so there's other things, I'll get to them in a second. I want to complete this part. So if you look at what this is doing, we are saying, all right, let's setf the properties. So EKG node is a struct, and the struct has the standard things like tags, text, etc. And then it could have anything else, right? We don't know all the data that could be in a node. Like there could be any sort of data, just like I don't know that someone's going to add to from, email to from CC. But if it exists, it's going to be in the properties, which is, you can think of it as like miscellaneous data that we don't have a strong opinion about. Like that's not part of core EKG. It's not quite true. Like things like title are there. But I think the point is that things we definitely don't know about are going to be there in the properties. So we just plist put on the properties this email to, which is, again, the type and the property. This is, you see this all the time in the triples package. We kind of sometimes refer, for various reasons, we sometimes refer to, we talk about the type and then we talk about the property separately, but then sometimes we combine them just for, ease of interaction into one, plist key. And in this case is colon, the type, and then the property name of that type. So email to. And that's it. Very simple. So just like, we're just putting it, we're just putting this email to, and then the value of whatever the EKG is seeing in this value into this property. And same thing with from, same thing with CC. Okay, so now the system knows how to get from that metadata property to the value that it could store. So now we're going to see how we can, some of these things store multiple things. And so we kind of have to understand there's two ways we can kind of display them in the metadata line. We could have comma separated values like tags, or like title. We want titles to be able to contain commas. So instead of having comma separated values, we have like title colon, title 1, title colon, title 2, and this is how we have multiple values. And we kind of have to decide which one of these we want. And for both of these, I think comma is very standard, so comma is what we're going to be doing. So this is all this is doing, is saying like for these things, multi-value thing, we're just going to have comma. And we also are going to then have to sort of go the other way. We have to say, okay, let's say we find a property we load it up. When we load up the note, we kind of will have the properties, all the properties. Even the properties EKG doesn't know about, because EKG just by default just knows about its own sort of properties. But it'll load up everything from all the triples associated with that ID. So it'll find something like email to if it's stored. So we have to say like, well, how do we do the other thing? How do we what is the label that goes with this? And so this is just saying we add to this EKG metadata labels and saying, okay, email to is going to be a label, like a metadata label, email to, and that's how it's going to show up on the metadata line. So obviously, like this and this have to be exactly the same thing, or it's not going to work well. Okay, then this is the last part. So now we know how to get from the ID, so from the property that we load to the metadata. How do we label it? And then how do we get from that label back to the properties so we can store the new value? And now there's one other part, which is that when you're looking at a display of a list of notes, how do we display it in that list of notes? Maybe you don't want to display it at all. And in that case, you don't have to do anything. And by default, it just won't show up. But if you do want to display it, you just write a function that has this standard EKG display note dash the type. Okay, and then this is responsible for displaying all the data about that type. So you'll get it gets the note. This function gets the note, and it will look in the properties for email to, email from, email CC, and it will just do some standard text to so that they show up in the list of notes. And okay, so that's it. That's all you have to do. Of course, it's not super exciting on its own. You'll just have structured data. The whole point is like, let's do something with the structured data. Let's make it useful for us. And in this case, I wrote something where we can create a note, capture a note directly from news, which is what I use to read email. Okay, I'm not gonna. Well, actually, let's go into a little bit. I don't worry too much about like how do we get everything from news. It doesn't really matter. What important is like we can get what we need to get. Then we could capture things. We could have the text be whatever we want to be, or not set it at all. That's fine. But then the important part is like we then also set the properties, and we have all these properties we want to set with the right values. And you do this, and what we should find when we run this function, this interactive function, so we'll be able to run it. And when we do that, so it'll capture something, and we'll be in the capture window, and it should have all the correct labels populated correctly. Okay, let's see this in action. So We'll go into GNU's. So I'm doing this from with a temporary database. So let's go to Emacs Devel. I don't know. Let's take a random message, and then we can run. Wait, what's it called again? It is called EKG email from news. EKG email from news. Okay, so we have a capture window. Let's see. Did it get everything? It did. So now we have these labels. They are correctly populated. Although I have a feeling that I haven't done this actual. I don't know if it actually. I might want to. I wouldn't be surprised if it stored both of these as one single value. I think I need to fix this, but it has the title, and you could change any of this. And we could have also made the decision to strip away everything except the email because we just want to be storing the email here. For me, I think I like having the actual more data, like actual names, and I'll show you why in a second. But here we have a note. You could do whatever you want to it, and we you could add your own text. Like, I thought this was interesting. And then we store it. And then let's just see, can we actually get it? Just show notes for today. Okay, here it is. And we do see it. Oh, somehow it's there 3 times. All right, that seems like a bug that I need to fix. So that's on me, but you can see our thing did work. it kind of, our thing to kind of like show our metadata inside the note. And we could open this up, and yes, we get these back. And we could change them. If maybe we want to, maybe I'm just gonna call him Ihor. And yeah, we can see it reflected here, etc. So now we have metadata, extra metadata that EKG doesn't even know about. And that's pretty cool. All right, but how do you, besides just having that metadata there, like why is it useful? Now that it's there, you can kind of use it for all sorts of things in all sorts of situations. I'm going to show you just like the very basic, but you can think of it like you could use it for completion if you want to. If you wanted to, if you wanted to get like a list of everyone who sent mail about a particular subject, or like I don't know, there's all sorts, like it's like any structured data, like you can organize it how you want to. You can get it it's very quick to both get and manipulate the data. So it's pretty nice to have this as structured data. I think you would find that it's much better than having it in files. So what I've done here is I've written EKG emails twos. It just is going to like get a list of the to fields, and I'm going to use this to have a function that gets all the notes with. Well, sorry, this is not used in this function, but like we have another function that gets all the notes that are to a particular value. And we also have a note, a function that we actually intend to use. This is the main function I kind of wanted to show off, is that like, let's get all the emails that show notes to a particular person. So now you have like a new way to show notes based on something interesting. But EKG emails twos. So, if I just do this, we could see, yeah, it's going to get a list of everybody. I only have one thing in my demo database, but like this just gets a list of everything. And how do we do this? Well, we get the type. Sorry, actually that's inside of a mapcan, but we start out, we get all the subjects of type email. That's the type the triple type we created earlier. And then we subtract from it the set of inactive node IDs. And we do this because we don't want it, this is not something that knows about anything. Triple subject of type, it knows nothing about any EKG subjects. But it just so happens that sometimes we don't want to display certain things to the user because things are trashed, maybe, or things are in the drafts. And, And so we do a seek difference of the EKG inactive node IDs. So we just, this is going to return a list of IDs. This is going to return a list of IDs. So by doing the difference, we'll have a list of all the IDs that are not inactive. And then we map over them, and we get, for each ID, which is, I'm calling sub, for the, this is a subject in the triple, we get the type from EKG-DB. How do you know EKG-DB is active? We just do EKG connect here, and that will guarantee that it will be active. And anytime you're doing something with triples, just have EKG connect in the top of your function. It's okay to just call it all the time. So we're getting everything with the subject and all the data of this type, email. Okay, so everything that has all the properties of this type, we're getting in a big P list, and then we're just getting the value 2 from it. So that will get all the 2 fields. So pretty simple, and that's how this works. And then we're calling seek unique because, of course, we could get many, and we kind of expect many things to have the same 2 fields. Okay, and then this one is this gets all the emails, get all the notes with a specific value of 2. So here we have this triple subject with predicate object. This is basically saying get everything in which 2 is 2, okay? And you might say like, oh, well, we could actually do this with what we saw before, which is having a virtual reversed thing. So we could say, let's just kind of like copy this and kind of do something similar here. And it should work. I haven't tried this, but like this is the way these things generally work, is that I could say, this is, email address. We'll say like, this is like email address. It's like and it has emails and email 2. Actually, emails 2. Yeah, I'm not sure how to. Naming this is a little tricky, but we have. Wait, how do we do this? It's just the other thing. It's just the other side, which is email/2. So we could have multiple of these things. So we could have emails from. Okay. So that should do the same thing. We would just be able to get that value and get everyone who every ID of everything that has this as an email too. These are equivalent. There's reasons that you might want one or the other, but like it's really just how much you think it should be sort of reflected in the data. And in this case, I think I'm not sure it makes complete sense. I kind of like having, I don't know, I'll have to think about it. Either way, I think is defensible. But here we're just saying we don't really need it because we are just saying like, let's just do a query where we're looking for every email 2 with 2 with this particular value as the object. And then we just get all the IDs, okay? And that is what we want to populate. That's going to be used to populate this EKG email show notes to, which there's a bunch of functions like this in EKG. And they all sort of do the same thing, which is we start with a completing read. We connect. We can't connect before interactive. Interactive has to be first. And so I guess technically we don't really need to connect because we'll have done it in EKG emails too. But then we set up the value. This is like what we title it. This is how to get everything. So we use EKG emails gets notes with 2, and then the value of 2 that it was supplied, and we sort by the creation time. And then nil is what tags this is. But there's no tags because it's not a tag kind of query. So yeah, so there it goes. It works. So this is like, you could say, okay, this is, you could add your emails. You can use them in all this ways you could use any other note. For example, everything here is visible if you're using the LLM stuff. Everything here is visible to the LLM, so you could ask notes about the emails you've stored. You could be like, oh, even like what's Arthur Miller's email address again? The LLM should definitely be able to figure that out. In fact, let's just try that now. I know this is a demo; these things never work, but yeah, what was Arthur Miller's email address? And what was he writing about?
Wait, you're drinking that still?
Yeah, so this did actually work. So you could see how kind of, especially when, like, for me, this stuff is super killer. Like, it's really useful to have this. So if you think like, oh, this is something I want to know about and I want to kind of keep in my memory, and I want that structured data because I want to be able to ask questions about that structured data. Yes, it is a great idea, I think, to do this kind of extension. So I hope this is useful. If you have questions about extending, like, put something on the discussion in GitHub. I'll have a link to the GitHub where EKG is hosted, and I think that we don't have. I might start a contribution folder for EKG, and then we could have. Maybe I'll add the stuff we just created, or something something else. But like, we could have a contribution folder, and like different people can add some things that seem interesting to them, and I think that would be kind of a cool idea. Thank you so much, and again, like, please come and start a discussion if you have questions on the EKG discussion forums. Thank you.